Hey there, and welcome to This Explainer. If you're an aspiring engineer, a student just stepping into the field, or honestly just someone who's totally fascinated by how the built world actually comes to life around us, you are in the exact right place. Today, we're taking a massive, truly comprehensive course from IIT Madras, the Introduction to Civil Engineering Profession, and we're distilling the whole thing down into a masterclass. We're talking about turning hours of expert lectures into a practical, step-by-step career blueprint. Because civil engineering isn't just one single job. It's this vast, incredibly interconnected network of specialties. And throughout this explainer, we're going to show you exactly how all those different pieces fit together to build the modern world. Okay, let's dive into this. We're looking at a four-part blueprint today. 1. Core foundations and structures. 2. Moving people and water. 3. The digital revolution. And 4. Management and professional skills.
Right, let's kick things off with Section 1, Core Foundations and Structures, because every grand project has to start from the ground up.
When you first begin your academic journey, you get introduced to these fundamental undergraduate disciplines. You can kind of think of these as the primary colors of civil engineering. First, you have structural engineering, which focuses really heavily on material properties. It's all about understanding exactly how steel, concrete, and timber behave under massive stress so you can design frameworks that are safe and efficient. Then you've got geotechnical engineering, which is literally all about the Earth itself. And finally, environmental engineering. This is the branch entirely dedicated to addressing the environmental impacts of our development and figuring out how to integrate sustainable practices right from the get-go. Mastering these three core concepts is absolutely crucial. It's your academic baseline before you ever step foot on a job site. Let's zoom in on geotechnical engineering for a second, because this is actually really fascinating. Before a single steel beam is ever raised, engineers have to master the literal ground we build on. This branch explores the incredibly complex mechanics of soil and rock. Why? Well, because geotechnical engineers are the ones calculating slope stability, testing soil compaction, and designing the foundations that safely transfer thousands of tons of weight directly into the earth. Without them, you end up with the Leaning Tower of Pisa, right? A gorgeous structure sitting on a terrible foundation. The most brilliantly designed framework in the world is completely useless if the ground beneath it just gives way. But hey, structural engineering isn't just about pouring fresh concrete and throwing up modern skyscrapers. As the IIT Madras curriculum beautifully highlights, a really crucial and deeply rewarding part of the profession is the structural conservation of built heritage. We've got centuries of historical buildings, monuments, and ancient infrastructure that require highly specialized care. Engineers working in this space use their deep knowledge of material properties to protect, reinforce, and conserve our history. In fact, becoming a heritage conservation specialist is a massively sought-after career path for graduates who really want to merge advanced materials science with a genuine passion for history.
Moving right along, let's shift gears to Section 2, Moving People and Water. These are the dynamic systems that keep our modern society flowing.
Now, what's really interesting here is the stark contrast between two highly specialized but deeply connected career paths, highway engineering and traffic engineering. On the strictly physical side, highway engineering is heavily focused on pavement design, the exact material science of asphalt, and the geometric alignment of the roads themselves. But on the operational side, traffic engineering isn't actually about the physical road at all. It's about the behavior of the things moving on it. Traffic engineers focus entirely on the safe, efficient movement of people and goods. They use complex modeling to prevent bottlenecks and optimize the overall flow. Basically, one builds the physical artery, and the other ensures the blood actually circulates.
And just as we have to manage the flow of traffic, we also have to meticulously manage the flow of water. Which brings us to hydraulic engineering and hydrology. This is about so much more than just putting pipes in the ground. It's about deeply understanding the entire water cycle, predicting rainfall patterns, and using fluid mechanics to ensure long-term water security. Think of massive, world-changing case studies like the Hoover Dam or the modern development of sponge cities. Whether it's managing intense stormwater runoff in a massive urban center to prevent catastrophic flooding, or securing a clean, reliable drinking water supply, hydrology is essentially the invisible shield that protects our infrastructure from both drought and deluge.
All right, on to Section 3, the digital engineering revolution. Time to shatter that old hard hat and concrete stereotype. Modern civil engineering is a profoundly high-tech reality. Today's engineers rely heavily on advanced digital tools that are radically transforming future construction methods. We're talking about predictive building now, rather than just reactive problem solving. We use highly sophisticated structural modeling software that can simulate the effects of an earthquake before a building is even approved by the city. We're talking about real-time sensor technologies embedded directly into our highways, feeding live, second-by-second data back to traffic engineers. And crucially, computational science and engineering, which means utilizing massive computing power to solve incredibly complex mathematical models that optimize everything, from material usage all the way down to wind resistance.
But here is where the true art of the profession really lies. A typical daily engineering role is basically a constant exercise in bridging the gap between two completely different worlds. On one hand, you have the computational office design. It's clean, mathematically perfect, and smoothly simulated in a climate-controlled, highly predictable environment. But then, that perfect digital model actually has to meet physical field execution. And out in the field, it rains. Soil behaves totally unpredictably. Supply chains get inexplicably delayed. The absolute mark of a great civil engineer is the ability to take those high-tech, complex office modeling tasks and seamlessly translate them into real-world, dynamic, and sometimes incredibly muddy fieldwork.
Which brings us to our final pillar, Section 4, Management and Professional Skills. This is the crucial glue holding it all together.
Let's just look at the story of a typical project from concept to final infrastructure delivery, say a brand new metropolitan transit system. The timeline is absolutely staggering. It begins with the concept phase, where early ideas and feasibilities are debated, often for months. Then comes the rigorous planning phase. This heavily involves environmental impact studies and intensive budgeting, which takes many more months, sometimes even years. And finally, the construction phase, spanning years of active building. When you graduate and enter a career path in infrastructure management, you aren't just thinking about what happens today. You are managing a living, breathing timeline that can literally stretch across an entire decade.
So to actually navigate that massive timeline, construction managers apply 3 essential steps every single day. First up is rigorous project planning. That means scheduling every single material delivery, every crane lift, and every concrete pour so that absolutely nothing stalls out. Second is stakeholder management, and I seriously cannot emphasize this enough. Stakeholders are often the most unpredictable variable in any project. This means you're constantly negotiating with city councils, addressing heated public concerns, and coordinating dozens of different contracting companies. And finally, overseeing the actual construction processes to ensure that every single thing is built safely and exactly to the specifications of the original design.
And this brilliantly illustrates a really vital tip for anyone transitioning from academic learning to professional practice. In university, your success is almost entirely based on your technical design expertise, right? It's your ability to calculate loads, analyze soil, and design beams. But out in the real world, to actually deliver a finished project, you have to balance that technical genius with project management skills. Suddenly, it's no longer just about the math. It's about budgets, tight timelines, clear communication, and actually leading teams of real people. Deep technical know-how? That's your entry ticket. But people skills, that's what actually builds your career. Now, woven through all of these technical and management skills is an absolute non-negotiable metric for the modern engineer: sustainability. This isn't just some catchy industry buzzword, it's a rigid, mandatory requirement that is heavily emphasized in the IIT Madras course. We are way past the era of building without consequence. Today, engineers have to actively mitigate the environmental impacts of their developments. This means actively selecting greener construction materials, designing for maximum possible energy efficiency, and integrating sustainable practices at every single phase of the project lifecycle. We aren't just building for tomorrow morning, we're building for a balanced future decades down the line.
Which really brings us to the ultimate challenge of your future career. We've seen how digital tools and computational science are giving us the power to design and build faster and much larger than ever before in human history. But just because we can build something rapidly doesn't always mean we should do it without some very careful thought. So, the big question you've got to ask yourself is this: as computational science accelerates our capabilities, how will you balance the intense societal demand for rapid infrastructure development with the absolute necessity of long-term water security and sustainable practices? It is an incredibly complex puzzle for sure, but as a future civil engineer, you are exactly the person society is trusting to solve it. Keep exploring, keep learning, and hey, thank you so much for joining me on this explainer.